a little bit about the SLP, okay, which is coming up here for the first deliverable in a week. I want to talk about the ODPs, the yesterday's and today's, and some general comments, and then I want to talk about some C. But before we get into that, are there any questions on anything, including those? All right, so let's start with SLPs. So your proposal is due in a week. It's due on the 10th. I just want to kind of remind you what you're trying to do here, right? So your goal in fall, SLP runs for 3 quarters. Your goal in fall is really to refine your proposal to a particular project, right? You want to figure out exactly what it is you want to do. So say you want to do something in AI, because AI is cool, but you're not sure what. Should I make something that plays a game? Should I make something that learns how to talk to you? Should I make something that controls a piece of hardware, right? How hard are these things? How would I go about doing it? I don't know. That's what you're doing in fall, okay? You're saying, here's the kind of thing I want to do, but I'm going to have to do some research. There's a 4-hour course I can take from Code Academy that will tell me about programming a machine learning system, so I'm going to do that. And then I'm going to look at these 3 things, and I'm going to see if one of those is something that I can turn into a project. That's a really nice idea for what to do in fall for your SLP, right? So that's what you could write up in your proposal, okay? It's not your final description of what you're going to do. It's not a finished product, right? It's where am I starting, basically? What do I want to do over the next several weeks? So cover page, right? First page should probably have your name, CSE 224, the date, name of your project, who you're working with, and so on. And then the rest of the document, probably start with a description, right? Put in some background if you want, but what is it that I'm thinking about doing, right? And just write a few paragraphs, however much you need to fully explain your project idea as completely as possible. And then start addressing these questions, right? So what's the most challenging elements? What are the expected learning outcomes, and so on and so forth, okay? Your goal is a PDF file, remember, that you could take to a venture capitalist and say, I want $1 million because I got a great project in mind. And they say, tell me about your project. You can hand them this PDF file and say, here, read about it. This will tell you everything you need to know, okay? That's what you're after. Does that make sense? So it's not this page with some words added in between. It's a whole document, as complete as necessary to address these and whatever else you think you need to address. Okay, you're not limited to this. This is a starting point. My offer remains, if you want to run a draft by me, if you want to come in and talk about ideas, or if you've written up something and you want to know how it looks, right? We can work on this and go back and forth. I'm very happy to do that. I'm not so happy to do it the day before it's due, though, okay? Because I'm going to get 60 or 65 of these things in my inbox. I'm not going to be able to do anything with them, okay? But you got a week right now until it's due, and I've already gotten this from some people. But if you want to, run a draft binder or something like that, feel free to do that. Did you have a hand up? No. Yeah. No. Okay. All right, so any questions on that? All right. I've failed big time on the class recordings a few times in the past week. When we've been doing stuff on the board, I've been trying to pause the recording so that we don't have dead space and people's conversations on there. But the recorder's not always wanting to come out of the pause state and stuff like that. So I'm just going to start the recorder in the beginning of class, turn it off at the end of class, and try to get every class uploaded. But if the class recording for this section isn't available, check to see if the one from the A section is. And the lectures are different, but they cover the same stuff. So usually there's a backup. All right, so let's talk about ODPs. If you write your ODP and it's not working, right, you can send me a note and say, my ODP didn't work, I don't know why, and I can sympathize with you, right, but I can't do much else than that, okay? You gotta give me something to go on. Show me your source code, show me how you tested your program, show me the assessment session, right? Go through all of that, copy it, paste it into a mail program, send it to me, and then we can talk. Always test your program before you assess. Assess is not a debug tool. Assess is a grading tool. You assess your program after you've written it and you've tested it and you've debugged it and you've made changes to it and you're absolutely convinced, I'm going to get 10 out of 10. I just know this program is perfect. Then you go ahead and assess. Okay? Because if you write your program and you haven't tested it, you assess, it says 0 out of 10. There's no information there. Why did I get 0 out of 10? Or you try it on one test case and it looks good and now you assess and you get 10 out of 30, right? It's not going to give you any helpful information. So you really got to do the testing yourself first. And test edge cases, okay? So 404, the goal was to write a program that takes two arguments, a word and a number. And it prints that word a total of number times. Okay? So for example, if you say script hello 5, it prints out the word hello 5 times. Are you done testing if that works? No. Because if you say script goodbye 3, it should print out goodbye 3 times. Some people try that, it prints out goodbye 5 times. Because they hardwired the 5. Some people, it prints out hello 3 times. Because they hardwired the word hello, right? So do all that testing. Test edge cases. What if you make that number 0? Does it print something out 0 times, which is what this says it should do, or does it print out an error message? If it prints an error message, it's not going to assess well, right? Try it with quote, quote for the first word, so the first word is empty. Make sure that doesn't blow up. Try printing 1 time, because 1 is always an edge case. Make sure if you say script hello 1, it prints out the word hello once and then exits. If your ODP is not giving you 10 out of 10 on every test, there's probably one of 3 things going on. 1, you don't understand what the ODP is asking for. Okay, like you thought it was supposed to print hello some fixed number of times, right? 2, you didn't test it thoroughly enough. There's some edge cases you haven't thought of. Or 3, there's just something weird going on, like you didn't say /bin/bash. Or you didn't make the file executable with the change mode command. Or you wrote your program ODP 404, but when you said assess, you were in a different directory, and there was no ODP 404, right? Or something weird like that. And you're welcome to send me an email and say I'm getting 0 out of 10. I don't know why. And if you give me all that information, I probably won't come back and say, oh, change I to a J and that'll work, right? I'm not going to solve your problem for you, but I may say something like, well, try running it with this test case and see what happens, right? And I'll try to point you in a useful direction that will help you figure out what's going on. Okay, does that make sense? All right, so let's look at 405. 405 opened this morning at 8:05. It's due tomorrow at 8. And 405 is a different kind of script. We can run it in 2 different ways. We can run it with a command line argument, okay, something we put on the same line. And in that case, what it should do is multiply that argument by 2 and print that out. But if we type in the name of the script, ODP 405 here, and there's no argument, it should do the following. It should print a greater than sign. That's a prompt. And it should wait for the user to type in a number. You type in a number, hit enter, it should print out twice that number. So it has 2 ways of running. It can run from a command line argument or from a program input. So let me show you what this looks like. I think I deleted this. All right, so here's my program try. If I just say try and there's no arguments, it prints a greater than sign nothing else, one character, and it waits for me to type in a number. And I type in a number like 75, and it prints out twice that number. If I say try, and I put in a number on the same command line, it doesn't print a greater than, it doesn't wait for input, it just takes that number, doubles it, prints it out. Right? Make sure it works with negative numbers. Make sure it works with 0. Those are probably your only edge cases. And I'm not asking you to do error handling in this ODP. So you can assume it's an integer. Right? And if it does this, go ahead and assess it. And you should be good.
What is the value of the second command line when there's no input? There's no.
I won't test it with no input, but if I do that, I think it's going to take it as a 0.
No, as in like try, and then there's nothing there.
Oh, you just say try? It prints a greater than and waits for you to type something in. So you type in a number, it prints out twice that number and exits. So it's always taking my number, doubling it, and printing it. But there's two ways I can give it my number. I can give it my number on the command line, or I can give it my number while it's running after it prints this prompt. And either way, it doubles it. And this prompt, when you say echo, use the -n switch. That'll say print out a greater than, but don't go on to a new line. So here's a script, right? It echoes a greater than, it reads a number, and then it tells me that that's the number I entered. So if I run that, it prints a greater than, but then it goes down to the next line, right? Because echo always prints a new line at the end. And I can type in my number. That's not going to give me 10 out of 10. So when you say echo, do this -n switch, which says don't do a new line. And now it prints a greater than, but it sits on the same line. It waits for me to type in a number. All right, so any questions on that ODP? All right, once you've got that done, you've got everything you need to do different versions of input to shell scripts. And we're going to start talking about C today, or right now, and we'll see different ways to input things into C programs that'll mimic these. So here's the first program we probably encounter in a C programming course like 121. This is the famous Hello World. Right. So Kernighan and Ritchie, who created the C language in the 70s, they wrote a book called The C Programming Language. And in the beginning of their book, this was the program they had, right? And they called it Hello World. And the idea was it's the first program you write when you're trying to figure out how to write in a language. Because it's about the simplest program that does something. It prints something out, right? And since then, basically every language, every system, every piece of hardware has a hello world. Right? On an Arduino, it's a blinking light. If you can make an LED blink, you know how to do a whole bunch of basic things. So this is sort of the starting point for learning how to program in C. So we've seen this program before. So we compile it. Usually we say gcc hello.c, and that leaves us. Well, we got a lot of stuff here. That leaves us a program called a.out. Okay, hold on. That's not us. That's the EMS system. Which should be giving us warnings, but it's not. Yeah. All right, so I just moved directories here. So we've got hello.c. So normally we say gcc hello.c, and it creates an a.out, right, which is our executable program. And we can say a.out, and it runs our program. It says hello world. All right. So one thing I've already mentioned is that sometimes it's nicer to not have our output always be called a.out. So we can put a switch, which is -o, which names what we want to call the output file. So I'll say let's call the output hello, and the input will be hello.c. Is there a question I can help with? You good? Okay. So this says go ahead and compile hello.c, but call the output hello. And the advantage is, oh boy. The advantage is that now my output executable is called hello, and I can run it like that. But if I write another program called goodbye, I can call the executable goodbye, and my executables don't all have the same name, right? So it's a way to organize your stuff better. So usually, I would say you probably want to be specifying an output file when you do this GCC. But be really careful how you do that, because when I put a command like this with a -o something, that something is going to be destroyed. Going to be replaced with the executable. If you accidentally name a C program in there, your C program will get clobbered. So be really careful how you use these things, how you order them. I don't know if this will actually clobber it or not, but let's see. So that's all kinds of bad stuff. And now when I look at hello.c, it's like it's gone, right? So what happened? Let's do that again. There's my hello.c. So this is what you don't want to do, okay? gcc-o hello.c hello. What am I asking it to do? Compile this thing called hello, write the output file into this file hello.c. So I'm asking it to overwrite my C program. And it will fail miserably. And hello.c is gone now because it didn't compile. Right? So hopefully you got backups, you've been putting things on flash drives, you're putting them into a subdirectory or something like that. If not, you're back to square one. It's a really horrible feeling when that happens. It happens to me. All right, so -o output file name and then the source files. That works correctly. All right, so let's start taking this apart. What does number sign include do? Do we actually know? We put it in every C program we write.
Does it include the source for all the standard?
Yes. So it includes the source for something called standard.io.h. So number sign include is what we call a preprocessor directive. And before we compile our program, we run what's called a preprocessor. And things like number sign include say, find that file, stdio.h, take all the stuff in there, and plop it right here into my program. Okay, I didn't want to write 1,000 lines of code up here, so it's already been written for me, but I want you to include that right here. So my 6-line program is actually like 1,006 lines, because it's got 1,000 lines coming from here. Okay, and this is pretty clearly saying what file it is we want to include. If we want to use square roots and sines, we say include math.h. That's a different file. All right, so where is this file located? It's not in my directory, right? All I got is hello and a.out. So where is stdio.h? Did you ever look for it? So directory structures. So slash is the top of the whole directory structure in Unix. It's sort of the root of everything. Slash bin is a directory that contains a bunch of programs. So for example, if I look in slash bin, there's all the stuff that's in there. And there's a program called bash. And we know about that. That's our shell, right? There's a program called cat. There's a program called ls. There's a bunch of programs in here. They're all the executable stuff that you do in Unix. And they're sitting under slash bin. Okay, slash home is another directory. That's where all of the user accounts are. So everybody who has an account, this is the directory that represents your account. Izad's down there at the bottom in the second column because I gave him an account when I set this up. There's me, Nick, next to Izad. And there's a few other things like test and test2, but pretty much these are all the user directories. All right, slash USR is sort of a general directory where we put all kinds of different information. Well, let's look at slash, right? What's under slash? There's bin. There's home in the second column. Here's USR down here at the end of the bottom row. And there's some other things like boot and etc and stuff like that. But let's look at USR. USR has a whole bunch of stuff in it. It's got its own bin, it's got some games, and it's got an include. And user include, that's where standard io.h is. Along with a bunch of other things. So here's stdio.h. And here is math.h. And if you've done mallocs and stuff like that, there's a standard lib, which is right here. And these are just files. They're just files sitting under this directory user include. So we can look at that file, and it's 946 lines, 31,000 characters, and it's got some comments in the beginning, and then it's got more directives, including things that say number sign include, number sign include. So include files can include other include files. And we don't usually try to deal with these things. These files are kind of mind-boggling. They've developed over a number of years, and they do all kinds of tricks in here and stuff like that. And we would have to do all of this, or some part of this presumably, if we didn't include stdio.h. But here's the main thing we're doing this for, is this line right here. So what is this kind of statement called? Do you remember from 121? It's a function prototype, or a function declaration, right? It's saying printf is a function, it returns an integer, and it's defined externally. You're not going to find the code for printf in this file. It's external. And it takes some arguments, and this is a funny type of argument list because it's got this ... in it, something called var args. But it's a prototype. It's saying, what is printf? It's a function. It returns an integer. It takes a car pointer, and then it takes some other stuff. And in our program, once we've done that declaration, when we come down here and we say printf, the compiler knows what printf is. It's a function. It takes a car pointer. It takes some other stuff. It returns an integer. So what happens if we don't do that include? Did you ever try that? So I'll compile this up. And it says, warning, warning, incompatible implicit declaration of built-in function printf. And then it gives me a very helpful hint, include standard.io.h, or provide a declaration of printf. So that's a surprisingly useful warning message. But it turns out I can still run my program. It happens to still work. But if you get a warning from your compiler, don't just go ahead and see if your program works. Because it may work in some cases and it may fail in other cases. So if you get a warning, you really got to stop, read what the warning's saying, and figure out where it's coming from. And you can decide, okay, I understand what that warning is, I'm not worried about it, and you can go ahead and run your code without a warning. Or you can decide, oh, I better fix that, and go ahead and fix it and get rid of it. And in this case, we would just go ahead and include standard IO, and then when we compile, it's happy. All right, so what's going on here? Integer main parentheses. Say again?
Also a function.
That's also a function. Right? This is how we declare functions. If you want to make a subroutine called sub, you say int space sub, parentheses, list any arguments, close paren, curly bracket. Well, that's exactly what we're doing here. We're saying int name of a function, parentheses, we're not specifying any arguments, curly bracket, ending curly bracket, and we're writing some stuff in here. This is a declaration of a function named main. That's all we're doing. There's nothing special going on here. Does it have to be called main? Will this compile if I call this something different? Like ha ha ha? Well, I can compile it. And I get some errors. But these errors look a little different from the errors we had before. In particular, it's saying userlib gcc x8664. And down here it's saying .text plus 20. And down here it mentions something called LD. So this is an error, okay? Our program will not compile and give us an executable in this case, but it's a different kind of error. So when we compile our program, we just say gcc program.c, and we end up with a.out, right? But there's a number of steps that are actually happening in here. So let me show you a hierarchy. We start off, we write some source code, typically something .c. The first thing that happens when we say GCC, this goes through a preprocessor. Which takes care of things like number sign include. If you do number sign defines, those are part of the preprocessor. You can actually do conditionals, number sign if, and so on. That's part of the preprocessor. And this gives you a bigger source code file. And then that goes through something called compilation. but it doesn't actually compile it into ones and zeros. Well, it does, or percent it doesn't. It doesn't actually compile into ones and zeros. This compiles into something called assembly language, or assembly code. And I'll show you what assembly code looks like. So I'm compiling with some other switches on here. -C says, don't build me an executable, just do the original compilation, but don't go all the way to an a.out. And -S says, leave the assembly language code intact. Normally it converts it to assembly language, it deals with that, and then it deletes that temporary file. But here we're saying keep that assembly code around, and it makes a file called hello.s. And if we look at hello.s, this is assembly language. Okay, this is the assembly language version of our hello.c. And it's got some stuff we can kind of sort of guess what's happening here. For example, there's a call. Okay, that's a call to a function. This says move a long word, 4 bytes. This says move a quad word, 8 bytes. Here's a push instruction. Right, so how many people here have done Engineering 270 already? Okay, so this is like the PIC stuff, right? Except PIC is a really, really simple language, and this is x86 code, really huge language, thousands of opcodes. Okay, but if we did this on a Raspberry Pi, we would see code closer to what the PIC has, because Raspberry Pi has a really limited instruction set. So we'd see, you know, compare and skip and things like that we're used to. If you do this on, you can get a C compiler from Microchip for the PIC, and you'll actually get PIC code. Right, you can get code that'll run on a PIC 18F1220. So we go through this process of taking your source code, adding in the preprocessor stuff, compiling it into assembly language, and then that gets assembled. And the assembler basically turns this into object code, which is ones and zeros. And the object code is still not ready to execute, right? Because when we compile this program, we've got the code that takes hello world in quotation marks and passes it to print and returns a 0 and so on and so forth. But there's no code in here for printf, right? And there's no code for printf in that include file. That include file is just prototyping different functions. It's saying what will printf do, what will it take in, what will it put out, but it doesn't have the actual code, the actual instructions that cause printf to be printf. That code is sitting in a library somewhere, a file somewhere off on the system under /usr. So that code needs to be combined with your object code, and that's what's done with a linker. And that's this program called LD. And that leaves you with an executable. Which is, if we don't do anything different, a.out. Oh, thanks. So object code goes through a linker, leaves you with an executable. And for us, we say GCC, all this stuff happens. And we don't have to know about all of these things going on. But these are all the steps taking place. So back to trying to compile hello, and it's giving us this error, and the last line here is telling us there's an error from this program LD. So what happened is we included standard io.h, that was fine. We compiled that into assembly language, we assembled that into object code, but down here when we tried to put it all together to make an executable, that's where we went wrong. Okay, so what went wrong in trying to make an executable? Well, we called our function haha. There's nothing wrong with that. That's perfectly legal. But when you're building an executable, you gotta have your main program named main. And the poor linker was looking for our declaration of main, a function named main, and it couldn't find it. And that's what it's complaining about. So why do you have to call your function main? Why can't I call my main program haha? Because how am I going to execute this program? I'm going to sit here at some prompt and I'm going to say hello. And I'm going to hit the enter key. Thanks. I gotta make something on here so when I start writing on here, it like picks up the pressure and it like flashes a light if I need to switch. That's a great SLP idea. So I'm sitting in my bash prompt, I say hello, I hit enter. How does my program start executing after that? What's the magic that causes my program to run and say hello world? You ever think about that? So at a high level, there's something that looks to see if hello is a built-in command. Do I know what hello means? And it doesn't. It's not part of bash. So it will look for a file in my current directory named hello. And it will find it because I did gcc-o hello. And then it somehow executes the code in that file. And then when it's done, it comes back to its prompt. And we're back to where we started. So right now, what's happening in this window? We tried to do GCC and we got an error message. What's happening right now in this window? Anything happening? Anything going on? Bash is waiting on input, right? There's a program running right now. You know what the program's called? It's called bash, right? It's a C program. And it's got a statement somewhere that says fgets, which means read from standard in until the person hits enter and take what they type and store it in this character array. And that's the program that's running, and it's waiting for me to hit enter. So I'm going to type in something. Well, it won't work right now. But I can type in something like date, right, and hit enter. And that program says, okay, the person typed DATE and hit enter. Do I know what DATE means? No. Maybe there's a program with that name, and it starts looking in different directories for a program named date. And it will find one. I think it's under /bin. And it says, hey, this person wants to run this program. Well, how does it do that? It basically takes the code for date. It's in a file right now, right? It pulls it into memory and loads it into a section of memory. So now we've got some locations in here which correspond to the code for this program date. And then it makes a call. It does a subroutine call to that first line of code. Now, how does it know where the first line of code is? Because it's labeled main. So if my program doesn't have a function named main, bash doesn't know where to start executing code. So the loader forces us to have a program, at least one function named main. All right, so bash makes this subroutine call to main, and now the program counter is pointing right here, and it starts executing the code in my file. And it will do that until it gets here. So what happens when you get to return in a function? 270 flashback. It returns to, yeah, the thing after the call. So down here we say return, and it basically comes back to whatever's after the call. So you get to the return, it comes back to whatever's after the call, which is something that does some final wrap up and then comes back and prints out a prompt and waits for another command. So when you write a C program, you compile it and you execute it, it's kind of becoming a piece of bash for a little bit, in some sense, right? It's loading your code into memory and bash is calling it and executing it, and at some point if your program says return, then it pops the return address from the stack, loads that into the PC, and it goes back to where it was in bash, and it continues. So all this stuff is integrated, right? The way that the operating system works, the way that your program executes, the way you go back and forth, right? All of this stuff is part of one kind of big unified story. And it's very similar to what we do in 270. It's just a much grander scale. And we return 0, right? Because we said haha is a function that takes an integer. Let me put this back to main. Right, we said return 0. And different systems have different ways of handling return values, but you could think of this as saying put a 0 into the W register and then do a return. And the thing that called you understands that your return value is in the W register. So there's some sort of protocol that's set up between the caller and the thing you're calling to get return values back. And in the case of bash, right, if you return a value, bash takes that return value and it sticks it away in memory somewhere, so that if you ask for the value of $? It gives you back that value. So that's how you pick up these return values from your main program. All right, good so far? These are things that you've seen before and you've done before, but I'm offering to look at them from a different perspective, right, through a slightly different lens, and think about what's going on underneath, right? Because that's a powerful way to get different insights into how all this stuff works together. All right, so let me ruin your day. We'll put in the famous argc argv in main, right? And we do this and we type it and it's always like this and it works, but we don't necessarily understand what it means. So let's take that apart for the next few minutes and then we'll call it a day. So integer main, integer argc, char argv, and a curly brace. So what is argc? Do you remember? I don't remember. Let's find out. Let's just print it. It's an integer. We can print integers. So I'm just going to print argc equals %d, and I'll replace %d with the value of argc. And we don't have to Google. We don't need the internet. We can just try this. So if I say hello, argc is equal to 1. If I say hello 999, argc is equal to 2. If I say hello, this is fun, argc is equal to 4. So now what do we think argc is? Yeah, it's how many things are on this command line, including the command itself. Right? If I put no arguments, argc wasn't 0, it was 1 because I said one thing, hello. Hello, this is fun, 4 things, even though the first one's the name of the program. Okay? That is different from bash. In bash, when you look at $, it's the number of arguments not counting the program name itself. So if I did this in a bash script, $number would be 3. That's an unfortunate discontinuity between bash and C. So just keep that in the back of your mind. All right, so argc will tell me how many things I typed on the command line. That's pretty useful. So let's look at this char ** argv. And C does not have a notion of an array per se, but we can do arrays a couple of ways. So suppose I say integer star a, right? So what is a?
Pointer?
It's a pointer to an integer. What else is a? Starts with an A. It's an array, right? This is the way that C codes arrays. So an integer *a is saying A is an array of integers. if I say character star S, that's a pointer to a character. It's also a character array. And what do we call a character array sometimes? It's also a string. If I say double star X, what is X? It's an array of doubles. If I say blah G with a star in front, G is an array of blah. Okay? So if I say car star argv, what is argv an array of? Character pointers, car stars, strings. So argv, when we do this, is an array of strings. Well, arrays we can put elements of, so let's do that. Let's print out argv bracket 0, and let's just do that. So if I say hello, this is fun, it tells me the first element of that array of strings is hello, which seems to be the function name, the program name. So let's print out some other members here. So now I say, hello, this is fun. Argv's first element is hello, second argument is this, third is this, and last is fun. But I keep printing, and the next argument is null, and the next argument is xdg session ID, and the next is term equals, and there's some other stuff in here. But since argc is 4, this is telling me that the argv array has 4 things in it, which means I should only ever look at argv's elements 0, 1, 2, and 3. Okay, argv is an array of strings, but in particular, it's these 4 strings. Hello, this, is, and fun. And how far does that go? argc tells me that. And if you look beyond that, all bets are off. There's a good chance your code will segfault. Okay? So we'll talk more about this on Friday. Tomorrow we're going to do Git and play with GitLab. And then Friday we'll come back and we'll talk about this some more. But this is how we're going to deal with command line arguments. And then we'll talk about how to deal with program inputs, and we'll talk about PA2. All right, so I'll see you next time.